Hello everyone, this is Professor Robert Solis. You'll have to forgive me if my voice sounds a little funny. I just drank some water, it went down the wrong pipe. So I'm sure my voice will clear as I keep talking. What we want to do in this particular lesson is to create a program that determines the average, the total, the minimum, and the maximum lap time for a race. So we're going to have the user enter a certain number of lap times for a given race. Excuse me. So in order to do that, what I'll do is I'll create a function called getUserData. I'm going to send to it a laps array so that I can obtain those values that are placed into that laps array. And then within calculate results, that's where I'm going to calculate all of these items, such as the average, total, min, and max. So over here, let me go ahead and create an array. So let's say this is going to be a collection of doubles, and I'm going to call it race lap times, and I'll put ARR to indicate that this is an array. You don't have to. I'm just putting that because this is going to indicate that it's an array for the race lap times. All right, now this is going to be 5 items. Now I don't want to do this. Could I do this? Yes. Should I do this? No, because that's hard coding. Probably the better thing to do over here would be to create a constant, and we're going to call that num of laps. Say, for example, it's going to be an integer. Sorry about that. So this is an integer. Num of laps is what we'll call it. And you have to give it some initial value. Let's say that that's going to be 5 laps. Well, now I can take this constant and replace that 5. And so now I'm no longer hard coding. If I want to change the number of laps, I can just simply change that here. So that designates and determines the number or how big this particular array is. Okay. Well, the first thing that I'm going to want to do is to get the user input. Well, in order to get the user input, I want to have a call to this function over here called getUserData. What am I going to send to it? I'm going to send to it the array called raceLapTimesArray. Excuse me. So I send to it this array, and now I have to obtain those times and place it into that array. So let me now scroll down, and here we are at getUserData. This is the function definition based on the function prototype at the top of the page over here. All right, so here's the top of the page. Here's the function prototype. Here's the function definition. All right, so if I get that, or if I get that array, I need to populate it. So we'll do this. We'll say, let's go ahead and create a for statement. I'll declare a counter that starts off at 0. So as long as this counter is less than the number of laps, right, that's the size of the array, then I'm going to do I++ propagate through each one of those different array elements. So what I got to do is I got to get the information from the user, so I could do something like this. Cout or I'll just say lap. Let me see here. I'm going to do something like, lap 1's time, lap 2's time. So let's see here. What is the lap time for lap 1, I guess? What is the time for lap 1? How about that? What is the time for lap? And then I want to put 1 there. So in order to do that, I'll just simply take that counter and add 1 to it, because you know that the counter is going to start off at 0. But if I add 1, that'll say lap 1, and then the next one will say lap 2, 3, 4, for however many laps that there are. And then what I'll do is I'll just simply put a colon with a space over here so that the cursor is blinking after that, waiting for the user to enter the time. What I'm going to do is I'm going to say cin. That's going to go into the array called lapTimesArray, specifically in that ith index. Well, as you can see here, the index starts at 0. So this will be lapTimesArray 0, then 1, 2, 3, so forth and so on. Right? So this is going to populate the array based on the user data. It doesn't return anything, but it populates the array. So let me just do a quick test, see what happens here. I'll stop the program here. Run it. Of course, we're not finished. I just want to do a quick test. Okay, so we're stopping here. Let's go into the array. So I'm going to step into. And now I'm being asked my first question, which is what is the lap time? I'm going to enter that. So let's say that that was 55.3 seconds. And notice that it says, what is the time for lap 1? All right, so now we're going to go back over here, and we're going to ask the question again, but for lap 2. So we'll say 55.4 seconds, and so forth and so on. So let me do this. Go over here, and I'll stop the program before it goes over here, and just continue. 55.5, 55.6, 55.7. So that should be the end. Pressing. Oh man, I wanted it to stop over here. Here we go. Okay, good. So it stopped here. Let's take a look at this array now. Ah, there we go. 55 point. Now this is how it looks like it's being represented in the CPU in memory, but it's actually 55.3. This is the designation right here. 55.4, 0.5, 0.6, 0.7. So it looks like it's stored all the data inside of the array, and that's exactly what we want. But notice this. This is the array, right? This is the array in the main program, but when we sent it, it's populating this thing called lap times array. What I'm trying to remind you of is that when you pass an array to a function, right here I should have said, when you pass an array to a function, you are passing it by reference. So you are passing the original, and the original is being modified, and so that's why when we return back to the main function, now that's the one that we were affecting, the original array, because that's what was being sent by reference to the function. Okay, so now I have the user data. Now let's perform a calculation. So that just simply means over here we're going to call a function called calc race results, and once again I'm going to send to it the lap times array, or I'm sorry, not lap times array, the race lap times array. There we go. And so what this function will do is it will calculate average lap time, total, min, max, so forth and so on. So in fact, why don't I do this? Let me split the screen. These are the things that I need to solve for, and we're going to do that inside of this function right here. All right, well, first of all, to determine the total, that's just simply going to be the sum, right? So I could do this. I could say, let the total race time be 0. Right? We're going to start that off at 0. And then with a loop, I'll just simply add all of the items within the array. So again, I can create a counter called I, as long as I is less than, what do I have here? Num of laps, okay? So as long as that's less than num of laps, which is the size of the array, and then we're going to increase that one by one as we propagate through this. So total race time is going to be total race time plus whatever is inside of the array index 0. So that's going to be lap times array, specifically the ith element. So at first this is 0. Then when we add something, it's going to be incremented, and then we just keep on doing this over and over and over again until we add all of the items in the array. So now I have the total race time. Well, if I have the total race time, in fact, let me just put a comment here. Calculate. Excuse me. And then okay, so that's what we're going to do in order. We've just determined the total sum. Now let's go ahead and find the average. I have a variable that has that. I'm sorry, I have a variable that's already been declared. And so the average will be whatever the total race time is divided by however many laps there are. Well, in this case, it looks like that's going to be a constant over here called num of laps. Now, here's the thing. It's not a big deal if I do this, right? Num of laps. This is a double. This is an integer. What will happen is this will be promoted to a double so that a double divided by a double will yield a double. If you don't like that, then you could just do something like this. Treat this thing temporarily as a double. And so that when I see something like this, what that tells me is that this must be something other than a double. So temporarily, I'm not going to change it, but temporarily I'm going to treat this thing as a double. So this thing becomes from 5 to 5.0. Because I am explicitly casting it as something other than what it is. Okay. Well, in order to find the min lap time, really what we're going to have to do is look through every single item within the array and say, okay, here's this first one. Here's the second one. Is the second one less than the first one? If it is, then we want to keep that. And then we just keep on propagating through the array to find the minimal value. So why don't I do this? First, let me set the min lap time to the first element of this array. Well, it's called lap times array. And I'll just set it, right? So we'll set the min lap time to the first array element. That's kind of like my reference. Like, imagine a photographer is trying to take a picture of a bunch of little kids. So what does the photographer do? Sets them up in order from shortest to tallest. Okay. So imagine these kids are not sorted. They're in all different orders. So I take this first kid and I use that kid as a reference, his height. And then I take the second kid and I notice that kid is shorter. So then I will swap. But notice that I had to start with one child first. And then I can do my comparisons. That's what I'm doing here. Let me start off with one value, and then I will do my comparisons for the remainder of the array elements. And remember, my goal is to find the minimum lap time. So while, actually, I don't have to do while. I can just do a for statement. So let's say for, and then int I, which is my counter, as long as I is less than the lap, number of laps, here it is. And then I++ to propagate through this thing. Okay. So if the min lap time is less than this particular array element, if that's true, then my new min lap time is going to be whatever that array element is. Otherwise, I just simply keep on propagating through the list. So I is then going to be 1. Is the min lap time less than, actually I got this backwards. Is this less than this? So I should have done this. Sorry about that. Is this guy less than the min lap time? Because if it is, then I want to capture that time. If it isn't, try the next one. Try the next one. So what this thing does is it just simply propagates throughout the entire array looking for the minimum lap time. Well, I can do the same thing for the maximum lap time. In fact, I think what I'll do is I'll just simply copy and paste this, and then I'll make some changes. Instead of min, of course, this is going to be max lap time. And again, I'll set it to the first element. Right? So set the max lap time to the first array element. I'm going to go through the entire list. If this is greater than the max lap time, then I want to remember that. Every time I find a value that's bigger than the one that I currently have, right? So if I have an item in my hand and the next one is bigger, well, then I'm going to get rid of the one in my hand. I'm going to grab the bigger one because I want the biggest jawbreakers, for example, right? So we're just looking for the largest one by propagating through this, and only if that item that we're looking at is greater than the one that I currently have, then I'm going to say, okay, my new max lap time is that particular value. Okay, so let's see. I think we've solved for everything. We've solved for the total race, the average race time, the min lap time, the max lap time. I think that's everything. So let me go ahead and go back to our main program. And it looks like that is going to be calculated. And so now we're ready for some output. So we'll say cout. And it looks like on the board I said the slowest, the fastest, the average, the sum. Okay, so the slowest lap time is, and I have that value. We're calling it min lap time. Actually, the slowest would be the max, right? Because how much? If you took longer to do a lap, then that's what that max lap time is. So it seems a little bit counterintuitive. Max lap time. And then cout the fastest lap time is min lap time. The total race time is, and I have that value, total race time. Finally, the average lap time is, and that is this guy here, average lap time. Okay, let's see what happens. Okay, so let's say 55.1, 55.2, 55.3, 55.4. Oh, 5 laps, 55.5. The slowest lap time is 55. Yeah, so it took me 55.5 seconds. It took me a little longer to race that particular lap. My fastest lap time is 55.1. The total average, or I'm sorry, the total race time. So I better double check that. So I have 55.1 plus 55.2 plus 55.3 plus 55.4 plus 55.5 equals, so that should be 276.5, yep. Now I take this and divide it by 5, then the average is 55.3, yep, 55.3. So our program works. Maybe I should put an end-del statement over here. So it goes to the beginning of the next line. Okay. And that is it. All right, so this is Professor Robert Solis. Sorry about all the hiccuping and coughing and all that other stuff that I went through. I'll probably have to redo this video sometime next year. But this is Professor Robert Solis. Hope you have a good day. See you next time.